In the last lecture we see the organ diagram, then modulus and argument of the complex number. Here the organs diagram means the representation of complex number as a point in a plane. That is, if z is a complex number, that is the x plus yi, then x comma y are the coordinates. Here for example, here z is equal to 3 plus 5y, that is 3 comma 5 is a point, okay, in a plane. Organs diagram, then modulus of the complex number. Modulus of complex number is denoted by, it is mod z or r, and it is under root of x square plus y square. Z is equal to x plus yi, it is a complex number, then it is a modulus. Then argument, it is tan theta is equal to y by x, that is theta is equal to tan inverse of y by x, and then theta represent the angle made by the point and positive direction of x axis, okay, made by the line with positive direction of the x axis. Therefore theta lie in a first quadrant, second, third or fourth, okay. Here theta, it is a 0 less than or equal to theta less than 2 pi it is a 360, okay. Here, and polar form, it is z is equal to r cos theta comma r sin theta. Here x is equal to r cos theta and y is equal to r sin theta, x plus yi, it is a polar form. And exponential form of complex number, it is z is equal to r into e to the power I theta. It is a exponential series, it is cos theta plus sin theta I, this represent e to the power I theta, it is the exponential series, okay. R into e to the power I theta, it is the exponential form of the complex number, okay. Now we see the example. Here if z is equal to 3 plus 5y, then represent z bar minus z and minus z bar as organs diagram, okay. Here given it is z is equal to 3 plus 5y, okay, it is a given number, okay. Therefore the z plus 5y, z is equal to 3 plus 5y represent as a point, okay, represent as a point. Here suppose a, it is 3 comma 5, okay, x comma y. Then z bar, it is a, z is a complex number, then z bar is a complex conjugate of z, then it is changes only in the imaginary part, it is 5i. Therefore we can write as a point b, it is 3 comma minus 5. Then minus z, it is a throughout multiplying by minus, therefore it is minus 3 minus 5i. Therefore third point c, minus 3 minus 5i. And last minus z bar, it is changes only in the sign of imaginary part, therefore point d, it is minus 3 comma 5, okay. Here representation of complex number as a point in a plane, okay. Here complex number z is equal to 3 plus 5y, z is equal to x plus yi, therefore x comma y is a point. Here 3 comma 5, 3 comma minus 5, minus 3 comma minus 5, and it is minus 3 comma 5. Then are the Cartesian coordinate, okay. Now here it is x, it is a real axis, it is y, it is an imaginary axis, okay. Here it is origin 1 2 3 4 and 5, 1 2 3 4 5, it is minus 1 minus 2 minus 3 minus 4 and minus 5, it is again minus 1 on the y axis, minus 2 minus 3 minus 4 and minus 5. Now first complex number, it is a z is equal to 3 plus 5y, 3 plus 5y as a point, it is 3 comma 5, it is 1 2 3, 3 comma 5, okay. Here it is a 3 comma 5, it is a point a, 3 comma 5 represent the complex number z, okay. Then again second point 3 comma minus 5, 3 comma minus 5, it is a z bar, it is 3 and it is minus 5 here, therefore point becomes here, it is point b, 3 comma minus 5, this represent z bar. 3i 3 minus 5i. It is a z bar. It is 3 plus 5i. Now next, minus 3 minus 5. It is minus 3 and it is minus 5. Therefore this become here. Okay. Point it is C. Minus 3 comma minus 5. It is minus z. Minus z. It is minus 3 minus 5. That is z minus z is equal to minus 3 minus 5i. And last, it is minus 3 comma 5. It is minus 3 and it is 5. Then here it is 5 minus 3. It is minus z bar, point D, minus 3 comma 5. It is a representation of complex number as a point in a plane, and it is called the Argand's diagram. Okay, see carefully. Now we see the next example. Find the modulus and amplitude for each of the following complex numbers. Okay. Now we see the first example. Under root 3 plus under root 2i. Under root 3 plus under root 2i. Okay. We find the modulus and argument, that is the amplitude. Okay. Here, let z is equal to under root 3 plus under root 2i. It is a complex number. We know that if z is equal to x plus yi, it is a complex number. Then modulus is under root of x square plus y square. Therefore, here, that is z is equal to x plus yi. Okay. Therefore, modulus of z is equal to under root of x square plus y square, and it is under root of under root 3 square plus under root 2 square, and that means under root 3 square plus under root 2 square, under root of 3 plus 5, sorry, it is 3 plus 2 and it is 5, under root 5. Therefore, modulus of z, it is mod of z or it is r, it is under root 5. Okay, it is the modulus. Now we find the amplitude. Okay, now, and it is tan theta for the amplitude. Tan theta is equal to y by x. Tan theta is equal to y by x. Therefore, tan theta is equal to y. It is under root 2 upon under root 3. Okay, and therefore we can write theta is equal to tan inverse of, here theta is equal to tan inverse of under root 2 upon under root 3. That is tan inverse of under root 2 by 3. Okay. It is the amplitude. Okay. Here the point under root 3 plus under root 2i, here both are positive. Therefore the point lie in a first quadrant. Okay. It is root, both are plus. Therefore point lie in the first quadrant. Therefore theta in between 0 to pi by 2. Okay. Here point point it is, that is Z under root 3 comma under root 2 lie in first quadrant. Therefore 0 less than theta less than pi by 2. Okay, that is theta becomes in between 0 to pi by 2. Okay, now next. Seven minus 5y. Next complex number, it is 7 minus 5y. Let z is equal to 7 minus 5i. That is the complex number z in a standard form, it is x plus yi. Therefore modulus of z, it is under root of x square plus y square. It is under root of 7 square minus 5 square. Okay, 7 square minus 5 square, and it is under root 49 plus 25, and therefore it is modulus of z is equal to under root 72. Okay, it is the value of r, that is the modulus of the complex number. Okay, now we find the amplitude. Okay, for the amplitude, that is the theta. Okay, first we write the, it is point lie in, it is the fourth quadrant. Okay, therefore here the point, the complex number. Okay, here the complex number z, okay, represented as a point is 7 comma 5 lie in fourth quadrant. Okay, lie in the fourth quadrant, that is it is 2 pi by 3, that is 270 less than theta and less than 2 pi in the fourth quadrant. Okay, see carefully, in a fourth quadrant it is x and y, it is 90, 180, 270, and it is 270 to 360, 270 to 360 in the fourth quadrant. Okay, now here therefore we can write tan theta is equal to y by x. Tan theta is equal to y by x. Then theta is equal to, tan theta is equal to here y by x. It is y minus 5 by x, that is 7. Okay. Therefore theta is equal to tan inverse of minus 5 by 7, and then we know that the formula for the tan inverse, it is tan inverse of minus theta is equal to minus tan inverse of theta. Okay, here we notation change karo, here tan inverse of, suppose a is equal to minus tan inverse of a. Okay, a. Okay, therefore theta is equal to minus tan inverse of, it is 5 by 7. Okay, therefore it is a modulus and argument. Amplitude is tan inverse, it is minus tan inverse of 5 by 7. Okay, see carefully, it is a tan inverse. Formula here we use tan inverse of minus a is equal to minus tan inverse of a. Okay, now we see the next example. Next it is minus 3 into 1 minus I. Okay, here the complex number is z is equal to minus 3 into 1 minus I. Therefore it is minus 3 plus 3i, it is the complex number. Therefore, modulus under root of x square plus y square, that is minus 3 square plus 3 square, it is under root of 9 plus 9, and therefore we can write under root 18, and under root 18 means 3 under root 2. Okay, it is a 3 under root 2, it is a modulus of z. Now here it is minus 3 comma 3, it is a point. Here z represent as a point, it is 3 comma 3, and it is lie in a second quadrant. Lie in a second quadrant. Therefore, here pi by 2 less than theta and less than pi. Okay, here in a second quadrant, here it is a pi by 2 angle make with positive direction of x-axis, and it is pi. Therefore, theta point is anywhere, theta in between pi by 2 to pi. In a second quadrant, the angle between it is pi by 2 to pi. Here now we find the amplitude, that is argument. Here tan theta is equal to y by x, and then it is y by x, y it is 3 upon minus 3. Therefore we can write tan theta is equal to minus 1. Now here tan theta equal to minus 1. Okay, then but here theta is equal to tan inverse of minus 1, tan inverse of minus 1, but here theta lie in between pi by 2 to pi by 2. Here we can, if directly write here theta is equal to, for as last example, it is tan inverse of minus 1, and then it is tan inverse, it is minus tan inverse of 1, and then minus pi by 4, that is 45. Okay, here theta make angle with a positive direction of x-axis. Here this angle and this angle, if this angle is 45, that is pi by 4. Okay, therefore it is tan minus 45 it is minus 1, but here this angle 45, therefore this 45, then the total angle is 135, and here the angle theta between pi by 2 to pi by 2, not here. Okay, negative angle, we want to the angle, it is in pi by 2 to pi. Therefore here we can write tan theta is equal to minus 1, and here minus 1 it is minus, and it is tan 45, that is pi by 4. Okay, we know that the formula of the allied angle, it is tan pi minus pi by 4. Okay, here we use the formula tan pi minus theta is equal to minus tan theta. Here it is given that minus tan theta, here it is given minus tan pi by 4, and this can be written as a tan pi minus pi by 4. Okay, here now therefore tan theta is equal to tan 3 pi by 4, and therefore theta is equal to 3 pi by 4 is the amplitude of z. Okay, 3 pi by 4 means 135. 3 pi by 4 it is 135. Pi is 180, and then calculate it is 3 pi by 4 it is 135. Now next example. Minus 4 minus 4i, minus 4 minus 4i. Here minus 4 square plus minus 4 square is equal to under root of 16 plus 16, that is under root 32, and under root 32 means 4 under root 2. it is the modulus. Now z represent the point -4 comma -4, that is it lie on third quadrant. Therefore the angle theta in between 180 to 270, it is 180 to 270, here lie in a third quadrant, 180 to 270. Okay, now here again it is -4 by -4 and then it is +1. Okay, here see carefully. Now it is a +1, then we can directly write the angle tan theta is equal to 1. Tan theta is equal to 1 means theta is equal to tan inverse of 1, and that is a pi by 4, that is 45 degree. But 45 degree lie in the first quadrant, but our point in a third quadrant. Therefore we know that the formula for the tan theta, here tan theta is equal to tan pi by 4, tan pi by 4 it is a tan 1, then tan theta is equal to tan in a third quadrant, it is pi plus pi by 4. Here we use the formula tan pi plus theta is equal to tan theta. It is a formula. Here the theta is greater than pi and less than 3 pi by 2. Okay, in between 180 to 270, that is lie in a third quadrant. Therefore we have the value, it is tan theta is equal to 1. Therefore theta is equal to tan theta is equal to tan pi by 4, that is theta is equal to pi by 4, directly can write. But theta is equal to pi by 4 means point in a first quadrant, but our point in a third quadrant. Therefore the value of theta is not equal to pi by 4, it is the value pi plus pi by 4, and therefore tan theta is equal to tan 5 pi by 4 addition, and therefore theta is equal to 5 pi by 4 is amplitude of Z. Okay, it is amplitude, it is not pi by 4. Tan theta is equal to 1, then we can directly write theta is equal to pi by 4, but theta is equal to pi by 4 means the complex number lie in a first quadrant, but here this complex number lie in the it is third quadrant, and therefore we can use the formula for the allied angle. Okay, tan pi plus pi by 4 means tan pi by 4, we use this formula. Okay, now next complex number, it is 1 plus 2i whole square into 1 minus I. First we write this complex number in the form of x plus yi. Okay, here let z is equal to 1 plus 2i whole square into 1 minus I. Okay, then solve this. Here whole square, it is 1 plus 4i and plus 4i square, a plus b whole square, and it is 1 minus I as it is. Now here 1 plus 4i and I square, it is -1, therefore it is -4 into 1 minus I. Then it is -3 plus 4i into 1 minus I. Again take the multiplication. Now here -3 plus 3i plus 4i minus 4i square, and therefore it is the complex number, it is z becomes, it is -4i square, therefore it is a plus 4, it is plus 4, I square it is a -1, therefore it is plus 4 minus 3, it is 1, and plus 7i. Okay, it is the complex number x and y, and then okay, तुम्ही स्टेप बाय स्टेप लिहा, मी डायरेक्ट लिहिलो. Therefore mod z is equal to under root of 1 square plus 7 square, it is under root 50. Okay, and theta is equal to tan inverse of y by x, that is tan inverse of 7. Okay, step by step व्यवस्थित लिहा. This point lie in a first quadrant. Okay, therefore theta is equal to tan inverse of 7. Okay, now this is the next. Okay, same example आहे. फक्त इथं डायरेक्ट x प्लस वाय आयच्या फॉर्ममध्ये दिलं नव्हतं. आधी मल्टिप्लिकेशन केलं अँड देन द कॉम्प्लेक्स नंबर इन द फॉर्म ऑफ x प्लस वाय आय. Now next example. One plus 2i upon 1 minus 3i. Find the modulus and argument of this number. Again same example. It is not formed in the x plus y or a plus bi form. Okay, it is the division of two complex number. Therefore first we take the division of two complex number, then the division of two complex number in the form of complex number, then we write x and y and then find the modulus and argument. Okay, here it is let z is equal to 1 plus 2i upon 1 minus 3i. Then for division we multiply numerator and denominator by conjugate of denominator. It is 1 plus 2i upon 1 minus 3i. Multiply numerator and denominator by conjugate of denominator, that is 1 plus 3i upon 1 minus, sorry, it is 1 plus 3i. Then take the multiplication. Here 1 plus 3i plus 2i and plus 6i square whole to the upon 1 minus 9i square. 1 minus it is 9i square, and therefore we can write here it is 1 plus 5i plus 6 into minus 1 upon 1 minus 9 into minus 1, and therefore it is minus 6 plus 1. Minus 6 plus 1, it is minus 5 plus 5i whole to the upon 10, and therefore z becomes minus 5 by 10, that is 1 by 2, plus again 5 by 10, that is 1 by 2 I. Then it is xy. Now here it is minus and it is plus. Therefore this complex number, okay, represented as a point in a second quadrant. Therefore theta in a second quadrant in between pi by 2 to pi, 90 to 180. Okay, in the second quadrant, amplitude, that is a theta, in between pi by 2 to pi by it is pi, that is 90 to 180. Okay, here this example for the homework. Okay, see carefully and calculate this. Okay.